Dynamo for Revit, Part 1. And it will look first at what Dynamo is and through the examples, first examples, which are in these notes. So first of all, to access Dynamo, we need to go to Revit, open a Revit file. Create a new Revit file, and I'll save it as Dynamo examples. I'm saving it in the downloads, Dynamo examples 1. And in the manage, I use the construction template this time. In the manage Dynamo, this opens the program. So Dynamo is a programming environment within Revit. It enables you to create a new file, open existing file, and also access some help sites like discussion forum, Dynamo Primer, and some tutorials, include video tutorials, and see some sample basic Dynamo files. We are starting with a new file, and this is the Dynamo Workspace. It's within Revit. You can still see the Revit window, or I can expand this. And in the new file, we can see the workspace. We can see the library with some sections, for example, maths, with the functions where we can have sine, cosine, absolute, and so on. Some geometry, for example, circle, curve. So all these commands, they are called nodes. The easiest way is to just type what we're looking for, and then or can be looked through by going through these directories. So in the view, we need to in the available previews disable Revit background preview, because that will take more graphics memory. And here, just to note that at the bottom of the screen, we have set at the moment the work to automatic, can be set also to manual. Automatic means everything is executed, all the commands are executed straight away. So we'll leave it like that for now. So the first example will be to create, just to mention that the units in Dynamo are the same as in Revit. In by default, in the Revit file, there will be millimeters. So at the moment, we have millimeters units. Let's start with the string node, which I will open. And the string node is used to place any text. So I can type here text. If I want to copy this node, I can press Control and then click on the top and drag. So Control and drag down. And now I have 3 strings, and I'm going to use now a function called concat, which concatenates the strings. Concat string, yeah. Oops, no, wrong one. Concat, yes. String concat. So this function will basically take 3 strings and join them together. So I can type here any text that I want. For example, Dynamo is space, and then in another one, software for visual programming. And now if I now use this, so this on the right side, this means output. So the output of the first string goes here. Now I can add here more strings to add to concatenate. So then the output of this string goes here, and the output of this string goes here, and this function will join these strings. And here, if I point, I can see the result. I put a dot mistakenly. So this one should not have a dot. Is let's see now. It needs a space. Okay, now it should work. So we can see the result by hovering over the bottom bit. And if we want to see it more clearly, we can use the watch node. Watch node is used to show the results. So watch, and then I connect this string to the input, and the watch shows. I will need to move everything this way. Okay, this does not show everything, but that's fine. So that is the example of operation with strings. Another similar example that I can add here, which is not in the notes, is with numbers. If I double click, I can put a code block, and code block is the general node. It can contain anything. So I can put in the first node code block number 1, in another number 2, and then I can look for plus. Plus, it's in operators. So plus, so if I feed here 1 and 2, I can copy a watch, node. Okay, so I copied the watch node, and then I'll just remove this one, connect it here. So the watch node will show the result, which is 3. The same result can be seen here. So this is just simple Dynamo program, adding strings or adding numbers. And I'll save this one as a string. I have already done it, but I'll just overwrite it, yes. Now, the new Dynamo program we can use to place a point on the screen. So to place a point, can just use the point node. And I can type here point, which will give me lots of options, but I want point by coordinates. So this point, this node will plot the point if I give it coordinates x, y, and z. If you see here, the default value is 0, so the point is already plotted basically. But if I change this, for example, by putting here 4 and feeding that into x, so now the x coordinates of the point is 4, and I can do the same for y. Then the y coordinate is 4, or maybe remove the x, so now it's moved in the x direction. or I can put this into Z, then the Z is 4. So this is what the point by coordinates does. And if I go back just to the notes, I can now create another point and then create a line between these points. And instead of just having one value for the for the coordinate, I can remove this and add something called a slider. And there is a number slider or an integer slider. Integer slider, let's use integer slider for now. Integer slider can have just whole values. So starting from 0 to 100, we can change it to, for example, starting from 0 and going to 15, or let's say 20, and maybe minimum, let's say, is 2, with a step of 2. So I can change all this. So now, instead of using a single number, I collect the slider with X. At the moment, the slider value is 2, so the X coordinate is 2, and I can go to the workspace, I can pan, and I can also rotate it to see it a bit better, for example. So now going back to the code, it is quite clear that by moving the slider, the X coordinate changes. And if I instead connect this to the Y coordinate, then it will be controlling the Y coordinate. So I can now, I'll delete the integer slider and use a more versatile number slider, because number slider can take any value, not just the whole value. But I make also the values from 2 to 20 with a step of 2. And I will now copy this slider. So the same slider copied twice. And now I can join these to X, to Y, and to Z. So by moving the values on the slider, we can control the coordinates of this point, first point. Now I want to plot the line. So if I search here for a line by start point, end point is the option. And I click on that, and it shows here the node, and it needs a start point and the end point. I have the start point, but I still haven't got the end point. At the moment, the default value doesn't exist. So what I can do now is create another point. I can, instead of doing it from scratch, I can just copy the first point, press Ctrl C, and then just paste. And it has placed this again, which I can now adjust maybe the slider slightly differently. And if I go to here, the 2 points now look like this. And if I connect the second point, the line is drawn between the 2 points. So by changing the coordinates using the slider, I can control how this point, first point, moves and also how the second point moves um, on the coordinate system. So how would it be best to see it? um, mm, yeah, so this is X, red is X, green is Y, and blue is, red is blue. So these are the 2 points. Maybe move it a little bit like this so it's visible when I unhide. So that was point, making a point in and the line in Dynamo. So I'll save this one. I'll call it a line. Now I'll create a new one, and I'll just double click, and in the code block I will create a line using just one code block. So instead of using individual nodes, all the, for example, point dot will give option by coordinate, doesn't by coordinates. Yeah, there it is. And I can just type the x, y, z coordinates. So let's say 0, 0, 10. That's the first point. Then I can just copy this and type it and do it again. But let's do now 10, 0, 0, for example. The second point is 10, 0, 0. And these 2 points are now plotted. This is the first point, and I can call this first point, for example, A. And second point I will call B. And now I can create line dot and then by start point, end point. So if I start typing by, it will come up with start point, end point. And I just want between A1 and A2. Oh, okay. I haven't put in the name of it. So I have to put the name for the line. And the name for the line, let's call it LAB equals line by start point, end point, A1. Oh, not A1, A2, it was AB. AB. All right, so maybe I didn't have to name it. Let's see. Yep, I didn't have to name it. So that has created the line between points A and B. If I were using this line later, I would need to name it, but this way. And I can rename this code block, for example, line. Two points. So instead of using something more elaborate, everything can be condensed in the node block. And this is sometimes quicker and easier to do, although it requires maybe more understanding. Now, the next option will be to create to plot a graph of a tan function. function. So we need to plot it for an angle from 0 to 89 degrees, and to before that we're going to do a range of points. So that is a very important block, not this one, delete. If you search for range and select, this type of node is very useful because it can create a range of values. So again, I will use a point by coordinates. And if I want to plot more than one point, I can put here the range. So for example, starting from 0, which is the default value, and is, let's say, 10. And step is 2. Default value for the step is 1, but step I'll make it 2. And connecting this to the x-axis, so this will plot 6 points. Also here, these 6 values that are created are shown. So what this range variable does is create a list of values starting from start value, which was default is 0, I didn't have to specify, then ends at 10, and the step is 2. If I made a step 5, it would have created just 2 points. If I made here 20, it would go to 20. So basically this is what the range does. It creates a sequence of values, and then these can be shown graphically as coordinates of a point, or and so on. So this range variable is very useful. And a similar way of doing the same thing is, instead of having the range, just typing in a code block the first value 0, 2 dots, the last value 2 dots, the last value 20, 2 dots, and step 5. And this, if I remove the previous one, it does exactly the same thing. So a range, and this is a quicker representation of this range, which basically creates all these values. So I will save this as range of points. Now, in the new file, we're going to plot a graph of tan. So I can just search for tan function, tangent. There it is. And it needs an angle. So I need to specify an angle. I can just use the code block. And let's say I want a range of values for the angle from 0, stopping at 89, and with a step of 3, actually. So this is the angle, and to see the results on a graph, I will I will put some points, point by coordinates, and I will specify that angle is the x value. So I have 89. Let's put a little bit less, 5 maybe, or 4. 4 would be good. And then this angle also feeds into tan, and the tan is plotted on the z-axis. So this means I have values for the angle, for the tan, and these feed into points. So on the x-axis we plot the angle, on the y-axis we plot the tan, and we have 23 points altogether, so for various value of the angle. If I go here, move it a little bit, so this is our tan function. If I want to plot a line, I can use another node called NURBS curve by points. NURBS curve by points. Yes. By control points. I think so, yes. So this will take a series of points and join them into and plot feed the line through them. So the output is a curve. And if we want just to show the line, so this is a line fitted through the points. It's not going to be ideal, but if we reduce the step, it's going to become a bit closer. And if I reduce the step even more, it will look a bit better. So now if I right click on the points and undo the preview, I can hide the points, so it's only showing me the graph, and this is a graph of a tan function, which when the angle approaches 90, the tan tends to infinity, because tan is sine of a cos, and cos of 90 is 0. So this was the graph of the tan function and the line, plotting a line of this graph. I'll save this as tan curve. And the next one will be now plotting a sine graph. So we now have sine. Right click sine. And we have again the angle, but instead of in the range saying what the angle is, I can use a range variable, or instead of a range variable, I can just set up the range with the variables. So instead of typing 0, 2.89, 2.2, I can type start, 2 dots, end, 2 dots, step. So this will create these 3 inputs. And for each input, I can use a slider, number slider. This is yellow because the inputs are missing. So number slider, I will specify it to go from 0 to let's say 90 with a step of 2. And I will copy this number slider once and twice. The end value I will set to start at, let's say, 90 and go all from 0 from 90 and go all the way to 720. That is fine. And for the step value, I will choose it from 1 to 10, let's say to 30, with a step of 5. So this, and this are giving us the angle. So if I click here, there are 90 values of the angle. So the angle starts from 1, ends at 90 with a step 1. If I change the step to 10, I can just type here 10. Then we'll have just 9 points. Now, this is now the sine, so I can use this angle to calculate the sine, and then I can plot points, point by coordinates. So the x value is the angle, and the z value is the sine. This graph, which I can pan a little bit, does not show the sine function very well because this is 90, and the sine is just 1. Maximum sine is 1. So I will need to multiply this function just in order to be seen better in the graph. And I will choose a multiplier just by using the node block of 50. So what I need in order to multiply this z, I need to multiply 50 by the sine and then feed that through. So I need again the times node. So in the times, I'm multiplying this and this. So multiplication, and then this will give me my z. So now if I look at the graph, this is much more visible than it was. And also, now that if I change this number slider for maybe end value of 180 or something like that, the points, more points are plotted, and by changing the step value, the points are now more spaced. And instead of using this as a code block, I could have used the number slider or an integer slider, it doesn't matter. If you want to multiply by the whole numbers, I can use integer, otherwise just a number slider. And this will be going from 1 to say 50 with a step of 1. And I will just connect that and remove this. So now I can control how these points move up and down. And in addition to that, I can now plot plot a line through these points. So again, NURBS curve by points. This one, and just the points are fed into here, and the line is now plotted. So by choosing end value, I can lengthen or shorten this graph. And I can also choose the start value and the step. This slider controls the multiplier sign. So this is basically a function. This is a graph of a function of a number times sine, so 50 sine or something sine x. Now, these sliders can be renamed to make them more meaningful. So the first one is the start angle for the graph. This is the end angle. And this one is the step. And the last one is the multiplier. Here, this code block basically represents the angle. And here we have, so we are plotting the graph for these 29 angles. And this is the function. And then this is the multiplication and plotting the points and the curve. We could now organize this a little bit better. So the first maybe like this. So the first 4 nodes can be grouped, edit, create group, and that can be group input. Not sure why it's not doing this. Input. These 2 nodes are create group analysis or calculations. And then these last ones create group geometry. And I can just change the color maybe. So now I can save this one as well. Sine curve